Right, I wanted to just kind of review series circuits here. Normally we'd have some time in class to do this. I know it's kind of hard to do it from home. I've cut out a bunch of the problems that we would normally do, but there are some key points to series circuits that I need everybody to understand, especially going into electronics too. You need to know that a series circuit is any circuit with one current path. Okay? That means that no matter how you draw it, it could be in a line like this with a battery here on the end, or it could be, the more conventional way that we draw it, like this. If you can take your finger and start at one or the other end of the battery and draw a line through the circuit and pass through every resistor in the circuit before you get back to the opposite side of the battery, you have a series circuit. There is only one path in this circuit. Same thing down here. If we were leaving here and we were trying to get to the other side, we'd have to go through that resistor, we'd have to go through that resistor, we'd have to go through that resistor, and we'd end back up at the beginning. That is the key definition of a series circuit. All right? Now, the next thing that we want to look at are the voltage drops in a series circuit. And so, no matter what your series circuit is, if you've got resistors in here like this, and we apply voltage to either end of this, so for example, we just put us a battery down here. Okay, I can make this battery any number that I want. Let's say I make it 12 volts. The voltages on those resistors are going to add up to 12. Okay, no matter what you do. You could make this one 4, this one 4, and this one 4. Well, 4 plus 4 plus 4, is 12, or 4 times 3 is 12. Now, if that happened, you would know that R1 is exactly the same value as R2, and it's exactly the same value as R3. It divided the voltage in thirds because there were 3 equal resistors. That's why a series circuit is sometimes called a voltage divider. All right? Now, they don't have to be even. You could take the same circuit, 1, 2, 3. You could put your battery down here like this, and this one could have 2 volts, and this one could have 6 volts, and this one could have 4 volts. Well, 6 and 4 and 10 is 2 is 12. That still adds up to your 12 volts at the battery, and so that's perfectly acceptable, but these resistors then can't all be the same value. In this circuit, this is the largest resistor, and we know that because it has the most voltage on it. This is the medium resistor, if you want to call it that, and this is the smallest resistor in the circuit because it has the least voltage. Something else that we can see here is these are proportional. So 6 is 3 times bigger than 2, so this resistor is 3 times the value of R1, whatever R1 was. Now 4 is twice as big as 2, so this resistor is 2 times the value of R1. So if you knew that R1 was 100, then this is 300, and then that's 200. And you could figure that out. That's true in any series circuit, and that's what the voltages do. And again, that's why this circuit is sometimes called a voltage divider. All right? Real quickly, you know that the resistors add, so I don't need to spend a lot of time on that. We know how to do that. It's just simple addition. Whatever your 3 resistor values are, if you had a 100, a 200, and a 300, you would simply add those up, 3, 4, 5, 6, 600, and that would be 600 ohms, and that would be RT. That's your total resistance. You just add them up. In parallel circuits, you have to use X-1 key, but in series circuits, you can just add them. All right? And finally, power dissipation. Basically, anytime current flows through a resistor, it slows it down because it's hard for the electrons to pass through the resistor. And because there are collisions inside of there between the electrons and the atoms, these resistors get hot and they put off heat. And heat rises here off of each one of these resistors. Well, that heat represents energy that has been converted from electricity into another form. And, you can't destroy energy. You can only change it from one form to the other. The job of a resistor is to slow down the current by generating heat. Some of that energy is converted into heat. Heat is measured into watts. And in any circuit, whatever heat that you are dissipating is the sum. So we would say P1 plus, I keep wanting to write an R. Get rid of all this mess here. All right. Well, that didn't work. Okay, good enough. All right, so go back to the pen. P1 plus P2 plus P3 is equal to PT. Whatever power you have. So if this was 2 watts and this was 6 watts and this was 8 watts, 8 and 2 is 10, you'd have 16 watts of power dissipated in that circuit. Those values are high. Typically you're talking about milliwatts, microwatts. You remember that your resistors come in starting at 2 watts, and then there's a 1 watt, and then there's a 1/2 watt, and a 1/4 watt, and even down to a 1/8 watt. So typically these wattage values would be very low because you've got to have a resistor big enough to dissipate that much heat. In this case, 6 watts and 8 watts, the only type of resistor, if you remember we talked about this, the only type of resistor that could take that much heat without burning out would be one of these wire wound resistors. It's made by just coiling up that special nichrome wire like your stove burner or your iron or your hairdryer's got in it. And that's what would dissipate that heat. This thing would just get red hot, and if you touched it, it'd burn you. You might remember the example in class. I plugged one in, and it turned orange. So we all saw that. Okay, so that's a series circuit. Now, the last thing that I want to review in this series circuit is shorts and opens, because series circuits can go bad. And so if you had a series circuit that was working normally, and let's say that we had 12 volts over here, and we'll just make these equal to make it even. So this would be 4 volts, 4 volts, and 4 volts. And so this circuit's working along normally. And all of a sudden, one of these resistors, maybe it overheats or whatever, the lead breaks off of it, and it opens. What's going to happen to the circuit? Well, you see, the problem now is there's no reason for the electrons to leave the negative terminal. You know, there's too many electrons here. They want to go to the positive, but they're not even going to start going around there because there's no attraction back to the positive on the top of the side of the battery. You know, we talk about pressure, but not only is it a push, it's a pull, and you've got to have this positive attracting this negative. Since that is open, this circuit is off. And the voltage on this resistor is going to go from 4 to 0, and the voltage on this resistor is going to go from 4 to 0. But now this is the interesting one. The voltage here is not going to be 0, and it's not going to be 4 anymore. It's going to be 12, because you remember we did that very first lab, had you open and close the light switch. The voltage on the open is equal to the source, or the total, or the applied voltage, and so that goes to 12, and the others go to 0. Now, the last thing here is what happens if you have a short in a series circuit. So that's kind of the opposite of an open. Here's our series circuit. We've got 3 resistors. We're going to put 4 volts on each one again, just like before. And we'll put 12 volts over here on the battery. 4 times 3 is 12. And so this time, let's say you're building this circuit in lab, somebody hooks it up wrong, or somebody drops something on the breadboard, whatever happens, and you short that resistor out. Now, usually a short's really bad, but in a series circuit, you've still got some resistance in the circuit, so it's not going to be catastrophic. You're not going to get smoke or fire usually. You could overheat your circuit, but typically what's going to happen here is this voltage is going to drop to 0, because the voltage across a short is always 0. And in effect, what we've just done is we've just taken that resistor out of the circuit. So let's say that each one of these was 1 k ohm when we started. Well, this one just went to 0 ohms. Now these two didn't change. They're still the same value. But this 4 volts... All right, I'm sorry, the phone rang there and I had to take care of that. So anyway, when you have a short in a series circuit, the voltage on the short goes to 0. Well, what happens to this 4 volts right here? It can't just go away because you're still putting 12 volts in over there. So watch what's going to happen. This voltage is going to go up to 6, and this voltage is going to go up to 6. And the reason is the 4 volts is going to be redistributed on the other 2 resistors, and since they are exactly the same value in this example, each one of those would go to 6. Now, if we had a situation where the resistors were not all the same value, so let's put the 12 volts down here, and let's put 6 volts on this one, and maybe 2 volts on that one, and 6 and 2 is 8, so this one would need to be 4 volts down here. So now we've got voltages here, and I could short out any one of these resistors. It wouldn't matter which. If I shorted out this 6 volt resistor and it went to 0, now that 6 volts has got to be redistributed on these other 2 resistors. But you can't just put 3 on each one because these are not the same. This one is twice as big as that one. So out of that 6 volts, twice as much of it is going to go down here as goes down there. So what we would see is we would see 4 volts being added to this one, making that 8, and then we would see the other 2 volts of the 6 being added to this one and making this 4, and then their ratio, 4 to 2, 4 is twice as much as 2, and here 8 is twice as much as 4. That ratio would be intact, and the shorted resistor goes to 0. So an open measures the applied voltage, a short measures the 0, and the other resistors change proportionally. All right, so this is the point where I'd normally ask, are there any questions? But, you can't ask any questions right now. But if you have a question, send me an email. If you're trying to do the problems and you can't do the problems, I'll send you a video example back of the specific problems you're working on. I can see your attempts in Moodle if you attempt the assignment, So go in there and try to do them. If you're having trouble, then just send me an email. I'll look at your attempts, and I can send you back some video help on the specific problems that you're working on. So just let me know if you need anything. Talk to you later. Bye.